let's take a look at the third problem. This problem is asking us to find the steady state currents of I1, I2, and I3. So what does this actually look like? So if we have our circuit here, we see that if I1, I2, and then I3 headed down. Now, approaching this problem, I don't see any switches, so that means that nothing's being opened or closed. So, we have to go ahead and assume that this has been in steady state for a long time. Okay, because I don't see anywhere for it not to go. So now we need to know how things interact, like element-wise in the circuit when they've had current running through them for a long time. So here, if I had a capacitor and I kept sending current through it for a long time, eventually it's going to clip itself out. Now, for an inductor, if we keep sending current through it for a long time, then it's going to act like just a wire. And why does it actually do that? We kind of touched on this in the past a bit, but a capacitor can only store so much. So once it's stored up, it's done. It won't accept anything else, and it's going to remove itself from the circuit. Okay. It says, even if you send something my way, I'm not going to accept it. And then with an inductor resists current flow. So if the inductor is resisting current flow, it's going to take a long time for that current to make it through this coils, but eventually it will. And once it does, it's just flowing evenly, just conservation of current flow. So what goes in, got to come out. So it just acts like a regular wire. Okay, so knowing that, we can go in here and identify a couple points that we have. So we have a capacitor and we have an inductor in here as well. So we can go and replace them with the steady state values, steady state elements after a long period of time, then we can better identify what the circuit's doing. So if I go in here and start drawing it again. Okay, so this is the capacitor that was there. We clipped it out. Oh, 200, 100, and here for simplicity's sake, there we go. So that was the capacitor, and this was the inductor. Okay, and we had currents 1, I2, and then I3. Now, we see that current can't go down an open wire, so we can identify that I1 is equal to 0 amps. Let's take a look at the right-hand side. So we see that if current is going to leave this battery, then it's going to travel down this way, bypass the open circuit, come down here, hit this point. It's not going to go down to the left side because it ends in an open terminal. So it's just going to send everything this way, and it's going to repeat the cycle. So that is showing us that I2 is equal to I3 because they're on the same branch. All right. So now to determine I2 and I3, what do we need to do? Well, if we take a look at, and it's not written in this problem statement here, I think I left it out by accident, so apologies for that. but IO is equal to 2 amps. So here we see I2 is equal to IO, which is equal to 2 amps. So therefore, we can say IO is equal to I2, which is equal to I3, which is equal to 2 amps. So this is our final answer. Apologies on this, but this needs to be in there, otherwise you can't solve that problem.